Hi, this is Pranay Sharma from S.Monk, and in this video I am going to talk about how we are going to write our Cs1 A examination in Word. Now the institute has provided us a list of notations that we are going to see further, but first of all I will talk about how we would prepare our Word file before starting the examination. Now you can see here it's very annoying, these red and blue marks that checks our grammar and spelling that we do not want it to check. Especially you can see that if I'm trying to figure out if there's a mistake in my sum, it becomes very distracting. So the first thing we are going to do is remove that. For that, just go to File and go to Options here, and in Options go to Proofing. When we go to Proofing, go down and you will see this hide spelling error in this document and hide grammar error in this document only. We'll select both of these, and while we are here, just go up and go to this autocorrect options. In this autocorrect options, just deselect this capitalized first letter of the sentence and capitalized first letter of the table cell. Sometimes we do not want capital letters, but it capitalizes it automatically, and that may be a problem. So that is why I deselect those as well. Now you can see it's much more clear and much more intuitive to understand or read these particular terms. Now let's go to the sheet that is provided to us by the institute. So here are some basic symbols that we can use directly. Our multiplication, division, you can see the approximately, you can use this similarity sign. Then inequalities, you can see less than equal to, greater than equal to. I'll talk about not equal to later on. Proportionality, you can directly write is proportional to, especially when we are talking about our posterior distribution. Square root, SQRT. Superscript, you can directly write a raised to x, or I'll show you another method later on. Subscript, x underscore, or directly xij. Exponential, exp, we have seen that before. Then for accent, where we have bar or hat, we can directly write b hat, x bar. Then for our Greek letters, we'll directly use the word. I'll show you later on. For infinity, we write I and F. For derivation, you can write f dash x, f double dash x, or df by dx. You can see here, you can directly write it in this manner. I prefer directly writing derivating with respect to this and directly write rather than these. It's just more intuitive for me. Integration is one of the most important ones. Whenever we have some limits to show, like integration, like summation, we use the bracket. See, int, then we have our bracket AB showing the limits, and then using colon, we separate our function. After integrating, we'll write in square brackets and then colon and then write the limits here. Okay, so this is how we will show our integration. Same thing with summation. You can see for summation, you will use the word sum, and then in bracket you can write your limits. What are the limits? And then you write your function here. Okay. So this is very much intuitive while using. We use product as well. Product a comma b and then the function. Expected value, variance. For given, we have this symbol just over enter. A straight slash. You can write given or you can use the straight slash. Okay. Then variance, covariance, I don't have to talk about it, but whenever we write distribution, especially this chi-square distribution, chi-square with degree of freedom m, you can see chi-squared and underscore m. You can use chi-square, you don't need to write d, but the name is chi-squared. Okay. So chi-squared and then write the degree of freedom. For our combination, we write choose and in bracket we write n comma r. Okay, this would be how we would write our combination symbol as well. So these are most of the symbols that we would be using. Now I've used some examples from different chapters to highlight how we would write it in our examination. So whenever we have Greek letters to use, we'll use a name and then just substitute it with a particular letter. Like here, nu I have substituted with V, lambda I have substituted with L. And then I've used that in my solution. Okay. I have highlighted my solution. You can see that here they had asked show that the cumulative distribution function was this much. So I've used and I have highlighted using bold. That way, whenever you're looking at the solution, it is easier for us to find what is the final answer. Okay. Then secondly, while writing integration, you can see integration, then limit 0 comma x and then f of x dx. This is how we'll write our integration terms. When we solve our integration, after solving and before substituting our limits, this is how we should write it, in square brackets and then writing the limits later on. Whenever we use our power, I have used superscript. You can write it in two ways. You can say it is x raised to v. This is one way of writing it, but I have found it becomes more complicated for us to understand or to check what we are writing. So I found it easier to use superscript. So I'll say x superscript. Here we have superscript. You can see here, if I click that and then write v, you can see our value is in superscript. But one thing is, if I keep on typing here, it will keep writing in superscript. I have to get down. I have to get my cursor down. I have to click that again and that becomes my back again, and now I can type whatever I want. Okay. So for writing anything in power, I use superscript. Keyboard shortcut for that is Control Shift and equal to or plus sign. So I'll say X, Control Shift equal to, and then V, and then I have to write it again so that it comes down. Okay, Control Shift equal to. Okay, and for writing subscript values, you can use this term here, subscript, or you can use Control and equal to. So if I want to write x1, I can write Control 1 and then back again is equal to whatever. So this way you can use superscript and subscript, or you can use your raised to and underscore to show that. Okay, x raised to v, this is also acceptable. X underscore 1, this is also acceptable, but it is not very visually intuitive for us to check later on. Then whenever we write a particular distribution, you will say x follows, this follows symbol. You will use shift and just above tab you will have that symbol. We have our normal distribution, our parameters. I have specified z is equals to our x minus mu by sigma following this. And I have, you can see, solved directly probability x greater than 35 converted into z. You can skip this particular step because you have already said what your z is here. You can skip the calculation part. You don't need to show all your calculation step. You can directly write p will be greater than this. Same thing here. You can skip this middle part, calculation part, and directly go to this z greater than this. Okay. You can see here for given symbol, we have p greater than 36,000 given our x greater than 35,000. So for that, you should not use your division symbol. Okay, that may be very confusing. So we'll say probability, then bracket, and then x greater than. Now see, for all of these, probability, p, bracket, x, and then greater than, for all of these I had my finger on shift. So our typing here is not the same as typing a particular paragraph. We use shift a lot. So you have to be very, you have to keep one of your finger near your shift all the time. So you have to practice a lot for this type of typing. And then given x greater than 35,000. So this is how you would write your greater given. Given symbol is above your enter. Okay, shift and that particular term. That is our straight slash. That is called as straight slash. You can see here mxt integration from minus infinity to 0, and then I had another infinity to 0 to infinity, because this is where you are solving. You can write the whole infinity, or you can just write I and f. That is understandable, it is infinity. So there are so many terms here, e raised to tx, and then e raised to minus x, that comes from this f of x. So it becomes difficult for us to follow steps many times. So you'll have to have practice. You will have to just try to read your solution again, so that when you're writing in your examination you can check, okay, and it would not be difficult later on. Okay, see the final answer I have again kept it as bold. Our expected value, variances, using our cxt. Now you can use space. Again, the more you use space, the more better your answer would look. Like here you can see that I have used int and then space, and then I have put the bracket. Then you can see I have another space, then dot, and then bracket. It's just visually easier for us to track what we have written. Okay. Then we have this joint distribution. For joint distribution, now these values you can directly make a table out of. Actually, I had just made this by copying this, because again these are all made by me, questions and stuff. So therefore it was easier for me to just copy and paste here and whatever. But whenever you have a table to make, how would we make a table? We'll go to our insert table, and you can insert table of how much ever number of columns and number of rows you would want. Let's say I'll make 3:3, but if I want to then insert another row, you can see here, if I keep my cursor here, gives me an option to add more rows. Here I will have for adding more columns, all I can do is select all of these, right click, and you will see insert column to the left, insert column to the right, insert row above, insert row below. You can use these as well to insert your row and column. Then whenever you're solving these kind of sums, these may be easier to solve in Excel, but it's not very difficult to solve it in our calculator as well. Okay, so called calculator table book. If you have physical table book, always keep it with you. The digital table book is also allowed, but anyways I would suggest, if you have physical table book, it's easier to go through rather than changing your page and everything. So whenever you are making table, you can use your insert table. So you can see I have used many different chapters. You can see again an integration sum. If you use your tab to align your values in this way, it's just easier for us to again track what's going on. Here all the equal to seems to be in one single place. It's easier to track. Again, you can skip a lot of steps. Whenever you are writing integration, you have to specify your function. This is our function, we have specified it here. Then you have to solve it directly. You can do this, directly solve this, and then directly write your answer. So any integration can be written in minimum of 3 steps. So you'll definitely require 3 steps. One would be writing the equation. The second would be solving the equation and then substituting the value and final answer. So your integration equation will have at least 3 steps. You can skip the other steps and if it seems not important. In this case, this is important because I have to specify what my equation will be. This is the substitution. I can skip this and I can directly write my integration, and then I can skip this step as well and directly write my answer. So whenever you are writing integration, because we are writing so many different steps, you can skip it. So I would always suggest solve it on the paper and then write it in Word. I know it would take a few, maybe a minute or more, but it would be easier for you to not make mistakes in that ways. So I'm not suggesting that all your questions should be written in paper first and then in Word. I would suggest only a few, especially the making equation of the integration part, that should be first written in the paper and then translate it into Word. Whenever we have our conditional expectation, they are very intuitive to write. There's not much to explain here. Okay. And using CLT, you can see CLT, not again much to talk about. Our normal distribution probability, I've written phi this, phi that. Use capital P for that phi. It just shows that we are talking about our capital phi, not our small phi. And for point estimation, many times we have to find our MLE, right? MLE of lambda. So again, we'll have long equations. So for likelihood function, I have written L lambda. Then you can see log likelihood function. So here again, you can see we have our product of, these are the limits, I going from 1 to n, and then f of yi. Then we substitute these all, I have taken directly out, and then exp, and then minus my lambda, and then sum this. Again, you can see that I have specified that my lambda is going to be L. Okay. So again, this is our sum. Again, I to n, I is equals to 1 to n, and then y cube. So it would be so much easier. First, I have a visual confirmation of whatever I am writing is correct. So I would write this first on the paper and then I will write it in Word. That is how I have done. I have solved all these sums. Okay, so log likelihood. Okay, then we have taken log. Okay, plus constant. Then differentiation. See, you can write differentiation here like this, or the other way would be just write differentiating with respect to, or just write WRT with respect to L. Okay, with respect to L, and you can directly write equal to this. Okay. It just, you do not have to write that symbol again here. This making this symbol might be a little bit difficult, might be taking more time, so you can directly write differentiating with respect to L. Then here you can write double differentiating. You can write double differentiating with respect to L, and this is how you can write. So you can explain your step instead of writing the simples as well. So we have our L hat. It just did not look very nice when I wrote it as L hat. So that is why I put a colon. Anything when you want to show that it is part of this same word but two different words, you can separate it with colon. So like here L hat, you can write it like this, you can write it like this. Okay, but anything whenever you need to separate and write two different words but that is part of the same symbol, separate it with colon. Then here we have our hazard function. This was the question of hazard function. Again, that is not part of our course. It's just something explained here in this question. Okay. Then when we talk about our confidence interval and hypothesis testing. Confidence interval, hypothesis testing, I have specified mu and sigma. I'll use this. For sigma, I have not used S because we use S for our sample variance. That is why I've used Q for sigma. Okay. x bar 1, x bar 2, n1, n2. You can see a 95% confidence interval for m1 minus m2. For mu I have used m, you can directly use mu. Okay, mu is not very difficult to write. And this is our confidence interval, x bar 1 minus x bar 2 plus minus, just plus and minus, and then z, you can see I have separated again it with colon, z 2.5%, and then square root of, these are sigma 1 square upon n1 plus sigma 2 square upon n2. So here we get, you can again skip this step, directly write your answer. Okay. Then here we had to calculate our pooled variance. So S1 square, S2 square, SP square. Okay, I have written pooled variance formula here. Pooled variance formula we should always write whenever we get a sum of it. Okay, I have skipped writing our standard deviation or sample variance formula. That is okay. Our H naught, you can see here, this is how we would write our not equal to. Not equal to, we'll write our exclamation mark and then equal to. This is a standard symbol of not equal to. Okay, so we have our H naught, m1 is equals to m2 and h1 is equals to m1 not equal to m2. Our test statistic, this is our test statistic, that is our t value. So I've written here our t value after substituting. See, I've written here t colon, and then I have said what is my degree of freedom, that is n1 plus n2 minus 2, all in bracket, because I do not want you to get confused that n1 is the degree of freedom and then I'm adding something. So that is why everything in bracket. Our p value, we know the p value formula. Okay. And then finally our p value answer. Same thing here, we have to prove whether our variances are equal or not. This is then test statistic, then this is our test statistic value, and then p value. Now every sum can be solved using p value. Okay, and I have done that. I have made sure that every sum has been solved using p value. It's just easier for us to write, okay, and easier for us to find as well. Okay, so even at 20% significance level, we have insufficient evidence to reject H naught. The variance of the male and the female sample are not significantly different at 5% level, because the question said check it at 5% level. So finally I have answered it at 5% level, but I have said that even at 20% level, we won't be rejecting our H naught. So again, you can see here, this is just the same question. So here, this is how we would write our confidence interval, and this is how we'll use our hypothesis testing. Okay. Data analysis, they have asked us to, in data analysis, we'll have literally 3 questions: find Pearson's, Spearman's or Kendall's correlation coefficient. Okay. So for that, Pearson's values, calculate these values. Okay. And you can write your R value. For Spearman's, you will have to write the ranks. So what I have done is I have not copied the data. I have directly written the ranks. Okay, so I have ranks and then d square, calculate the sum of d square. Same thing for Kendall, all we have to do is find how many coordinates or disordinate pairs do we have. So I have done that directly. Okay, we do not have to write long equations, or we don't have to show long tables. Most of the tables we can directly use it from here. Then our linear regression, they may ask us to draw a scatter plot. Now I have drawn this scatter plot diagram in Excel, or I think we can draw it here directly. Yes, so when we go to insert, you will have chart. In chart, if you use the scatter plot diagram, right, this is our scatter. You have different types of diagrams, but we'll be using mostly scatter plot. Use this one. Okay, and when you do that, it will ask you for the data. Where did it go? Don't know where I inserted the scatter plot. Let's say I'll be inserting here. Let's say insert chart, go to scatter, select this scatter plot diagram, press OK. So it will insert a scatter plot diagram with sort of a small spreadsheet here with your X and Y values. All you have to do is insert your X and Y values and make sure that all your values have been selected. So as soon as you start inserting, let's say 1, 2, 3, 4, 5, 6, 7, you can see that it is already selecting all your values, and Y values you will, let's say it's 1.2, 1.4, 0.9, 2.7, let's say 2.2, 1.9, and let's say 2.9. Okay, so this is how your value is going to look like. This is our scatter plot diagram. Let's say this is 1.9. Okay, you can see that this is our scatter plot diagram. Okay, you can see this scatter plot diagram. You can draw scatter plot diagram in this manner, or you can do one thing, use your R and then make scatter plot diagram there and then copy paste. That is also acceptable. Okay, whenever you are writing a scatter plot diagram, a few things that you should make sure is write your x-axis and y-axis values here, like I have written here. See, you have trips and you have maps. Okay, now for that, how would we do that? You just click anywhere, let's say in this corner of this map or scatter plot diagram, and then press this plus sign. In this plus sign, you have different options. Axis title. Okay, so we want this axis title. As soon as we press this, you will have axis title here. You will write whatever your title is. So let's say this was trips. This was maps. Okay, you can write here the main title. It is trips versus maps or whatever, but I prefer to just remove it. Okay, so I'll just delete it, and this is your scatter plot diagram. Delete this. This is the scatter plot diagram from this data. This is how we would solve our CS1 A paper in Word.